6.1 Part 2. Okay, so we've been given the point -1, -4 in the terminal arm of angle theta in standard position. Determine the exact values of 6 trigonometric ratios for theta. So first of all, don't ever forget this. We use that a lot. So this point lets us know that x is -1 and y is -4. So we need to find r. So we're going to find r by doing the square root of x squared plus y squared, because we can imagine this as a triangle. So r is going to be -1 squared plus -4 squared. Be careful, those will go in brackets. So this is the same as the square root of 17. So determine the values of the 6 trigonometric ratios. So be careful with these negatives. So sine of theta is going to be -4 over root 17. You can also be able to tell that this is in quadrant 3 because it's over 1 down 4. So it's like that. So it makes sense that sine is negative. Cos theta is equal to -1 over root 17. Tangent theta is equal to y over x, so -4 over 1, which is the same as 4. Now we can do our reciprocals, so cosecant theta is equal to root 17 over -4. Secant theta is equal to root 17 over -1, and cotangent theta is equal to, that's supposed to say negative there, 1 over 4. So there's all of our trig ratios. Okay, suppose that secant theta equals 4. Determine the exact values, so exact, that's important, the exact values of the other trigonometric ratios. So first of all, this is the same as saying 4 over 1. And secant is the reciprocal of cosine. So I could rewrite this as cosine theta equals 1 over 4. So that's handy to us because now we know that this is equal to x and this is equal to y. So x equals 1, y equals, nope, that's not a y, it's an r. So r equals 4. We need to figure out what y is equal to. We can also tell which quadrants this could possibly be in. So because cosine is positive, it could either be in quadrant 1 or it could be in quadrant 4. So it's not going to be in these quadrants at all. And because we're only going from 0 to 180, which is from here to here, we're only going to have one answer for this question. So we're going to find y, so we're going to go x squared plus y squared is equal to r squared because we know it is a right triangle. We know x squared is 1. We do not know y squared, but we know r squared is 4. So we have y squared is equal to 4 squared, subtract 1 squared, and then we square root. So you have square root of 16 minus 1, so we have the square root of 15. So now we can find all of our ratios. So we're going to say sine of theta would be the same as y over r, so root 15 over 4. Cosine theta is the same as x over r, so 1 over 4. Tangent theta is the same as y over x, so root 15 over 1. Cosecant theta is equal to the reciprocal of sine, so 4 over root 15. Secant theta, we already know, is 4 over 1. And cotangent theta is 1 over root 15. So if our domain was differently, we might have been able to have an answer here, but because we don't, we only have one solution, and these are our solutions. Okay, last example. To the nearest degree, determine the possible values of theta in the domain. So back to what we were just doing, we can use any single one of those ratios to find our angle. So let's use cos to the minus 1. So we're going to use cos to the minus 1, and our cos ratio is 1 over 4, and I get 76 degrees. So this is asking us to go from negative 360 to positive 360. So we know that it can be in this quadrant and it can be in this quadrant because cos is positive here and sine is they're all positive here. So one of our solutions is 76 degrees. The other solution would be from here to here, which would be 360 subtract 76, which would be 284. We can also do, because it goes from negative 360 to 360, we can do the negatives of these. So this angle right here would be negative 76 degrees. And this angle right here would be negative 284 degrees. So those are our 4 answers. Okay, that's all I have for you. Thank you for coming to my TED Talk. Bye.